Hello my dear student, today we are going to discuss about the applications of the Bohr's atomic model. You know that the Bohr's atomic model is an outdated concept that we are not using at the present time, but their applications are important for your school examination, NEET and JEE examination. If you know about the basic postulates of the Bohr's atomic model as well as its limitation, then you are at the right place to learn about the applications of the Bohr's atomic model, that is the numerical related to the Bohr's atomic model. Before starting to the applications of the Bohr's atomic model, I think it is better to know or to revise about the postulates of the Bohr's atomic model. Let's start. Be energetic, listen carefully. You know, it is the structures of atom. Before starting, I want to make it clear to all of my dear students that Bohr's atomic model is based on the particle nature of atom. It means Bohr's atomic model assumes that the atom is a particle. Also, the biggest disadvantage of the Bohr's atomic model is this: it is valid only for hydrogen and hydrogen-like species. At present, we have more than 120 elements, but it is valid only for hydrogen, so it seems not good. But my dear student, applications of the Bohr's atomic models are important. According to the Bohr's atomic model, an atom consists of heavy, dense, positively charged center called nucleus, around which the electron revolves in a fixed circular path. In a fixed circular path, these electrons are revolving, and these fixed circular paths are called the orbit, energy level, or shell. Also, these orbits are called the stationary orbit. Stationary doesn't mean that the electrons are not moving or at rest. Stationary means that the energy of the electron revolving in a particular orbit is constant. Okay, but this word little confusing, that stationary orbit. Stationary, remember, it doesn't mean that the electrons are at rest. Electrons are continuously moving. Even in lower classes you learn that all the matter particles are continuously moving. Okay, and another point, as long as the electron keep on revolving in a fixed circular path, that is in a particular orbit, the energy of the electron remain constant according to the Bohr's. But as the electron jump from one energy level to the higher energy level, its energy increases, or electron gain energy to go from K shell to the L shell, or from L shell to the M shell. Similarly, if the electrons come back to the lower energy level, it loses energy. So, electron jumping to the higher orbit level, higher energy level, and coming back to the lower energy level require the exchange, that is lose or gain of the energy respectively. And also, according to the Bohr's atomic model, you all know that there are infinite orbits. Oh, it seems confusing, infinite orbit. Only a few teachers will tell this. Among these so many orbits, infinite orbit, I am using this word, only electrons will revolve in those orbits where the angular momentum of electron, that is mvr, is equal to h upon 2 pi. If it is first shell, it will be 1h upon 2 pi. If it is second shell, 2h upon 2 pi. If it is third shell, it is 3h upon 2 pi. So better to write nh upon 2 pi. It means electron, out of so many orbits available, or the possibility of so many orbits, electron can only revolve in those orbits where the angular momentum of electron is the integral multiple of h upon 2 pi, where the value of n starts from n is equal to 1, 2, 3. So it is the lowest value of n is 1 and up to infinite. But practically there is no need to draw all the infinite orbits. Okay, my dear student, without wasting the time, let's discuss about the limitation. Because if I start directly the application, some of the students think, oh sir, I don't know about the Bohr's atomic model. So please let me explain first about the Bohr's atomic model. That's why, taking care of you, I explained these postulates of the Bohr's atomic model, and now I'm going to explain about the limitations of the Bohr's atomic model. I think in the beginning, my dear student, I explained the limitation that it is only valid for hydrogen and hydrogen-like species. First limitation. Second is that it could not explain the hydrogen spectra or even the spectra of other atom, the splitting of the spectral line. I think you all know the Zeeman effect and the Stark effect. Zeeman effect is the splitting of a spectral line in the presence of magnetic field. It could not explain the splitting of a spectral line in the magnetic field. Bohr is a very great scientist, but he is not able to explain why the spectral line is getting splitted when it's placed in the presence of the magnetic field. Also, when the spectral line are placed in the presence of the electric field, Bohr's confused why these rays are getting splitted. When someone asked why these rays are splitted, he is not able to explain. It means, again, my dear student, he is not able to explain the Stark effect. So, splitting of a spectral line in the presence of magnetic field is called Zeeman effect, and the splitting of a spectral line in the presence of electric field is called Stark effect. I think it is the brief introduction about the Bohr's atomic model. So let's start these points, that is the radius. In this video, I will discuss about the radius and important formulas. From these shortcut formula directly, important question will be asked in the NEET, JEE and other competitive examination where chemistry is one of the subject. So important points you have to write. Take the pen and a copy and start writing the short formulas. I'm not going to teach like the usual method, learning the long way. I will teach you important formula and shortcut tricks to solve the numericals in short seconds of time. Okay, let's start. Radius. You know, the radius is the distance of electron from the center of the nucleus. The distance between the center of nucleus to the electron. But later, I think you all learned the Bohr's atomic model or the atomic structure chapter. Later, all these concepts is outdated because it is based on the particle nature. Radius of electron. Radius of shell or orbit, if we have to calculate, we are representing Rn. Rn means R means radius, N means nth orbit. R1, R2, R3 we can calculate. So the radius of any nth orbit is given by A0 n square. A0 is the radius of the first orbit. What is it? Radius of the first orbit, or we can call it as Bohr's radius. Okay. So radius of nth orbit is equal to A0 n square upon Z. Can anybody tell me what you mean by the word Z? Z is simply the atomic number, because this model is valid only for hydrogen and hydrogen-like species. If any other element that is similar to hydrogen, it means its atomic number may be different. So we have to place the atomic number also. So remember, my dear student, this formula, radius of a shell or an orbit, is calculated by A0 n square upon Z. But if it is only hydrogen, so we can calculate the radius of nth orbit by A0 n square. A0 n square. If it is confirmed that the given element is hydrogen, if something is like hydrogen, hydrogen-like species, I will discuss about the hydrogen-like species within a few minutes. Then we will use this formula where A0 is the radius of the first orbit or the Bohr's radius. Remember, this value is calculated by the Bohr's. The radius of the first orbit, that is A0, is 0.0529 angstrom, or I can write for easy calculation 0.53 angstrom. Okay, and also in picometer we can write as 52.9 picometer, or in nanometer 0.0529 nanometer. I think you all know from the physics that angstrom is equal to 1 angstrom is equal to 10 to the power minus 10 meter, 1 nanometer is equal to 10 to the power minus 9 meter, and 1 picometer is equal to 10 to the power minus 12 picometer. Okay, remember this formula. You can also take the screenshot. Now we are ready to discuss the limitations that valid only for hydrogen and hydrogen-like species, or I can use the word monoelectronic, or in some books you may found that uni-electronic. unielectronic species. The example of unielectronic species are He plus. You know the atomic number of helium is 2. If it is He plus, it means one of the electron is removed. If atomic number is 2, there are 2 electron and 1 electron is removed. It means He plus is a monoelectronic or single electron species. While Li2 plus, how many electrons? Because the atomic number is 3. If I am removing plus 2, it means 2 electron, it is only having 1 electron. And Be3 plus, atomic number 4, we are removing 3 electrons. So this can also be the example of monoelectronic species. It means hydrogen, Bohr's atomic model is valid for hydrogen, and hydrogen like He plus, Li2 plus and Be2 plus. Remember this point. Another point, you are thinking, some of the students asking me inside the classes when I was taking online classes as well as in the coaching institute, they are asking, sir, from where Bohr is able to find out this formula? I'm using this formula. Bohr concluded this formula from a very complex formula. Don't take attention as it is mentioned here. So complete formula Rn, radius of nth orbit, is equal to n square h square upon 4 pi square mkze square. This is the formula, very complex. Some of the students are thinking, what this, sir? So that's why I make it simple for you. You have to remember only the simplest formula. I always teach the simplified version of the chemistry. Now, the next topic that I am going to teach you is not for school examination. It is for the examination like NEET and JEE. If you are preparing for the NEET and JEE examination, you calculated the radius of an orbit. Now, there is a time to calculate the radius of nucleus. Radius of nucleus. You know, while I was discussing, most of the time you can see my videos on the YouTube also, that we can relate the atom and the nucleus as like a very big playground is there. At the center we have a small football. Football could be considered as a nucleus, while the whole playground is like a atom. We can correlate as an analogy. Okay, so the radius of nucleus is very small. Radius of the atom, this question in previous series asks that the radius of an orbit is related to the shell number, but the radius of nucleus, listen carefully with both the ear. Radius of nucleus depend upon the mass number. How many protons and neutrons are inside the nucleus, it increases the size of the nucleus. So radius of any radius of a nucleus R, we are denoting it by capital R. Remember, my dear student, radius of orbit we are denoting by small r, but the nucleus is always denoted by the capital R. Radius of a nucleus R is equal to R naught dot or into A power 1 by 3. A is the mass of the atom where the nucleus is present. Okay, R naught is the radius of the simplest of first radius. Just like we are calculating A naught we are considering, simply we have R naught, where, my dear student, R naught is equal to 4 by 3 A 10 to the power minus 13 centimeter. 4 by 3 10 to the power minus 13 centimeter, or we can also write as 1.33 into 10 to the power minus 13 centimeter. You have to substitute this value while calculating the radius of the nucleus of any atom. For example, if I consider the radius of a nucleus of aluminum, what is the mass of aluminum atom? Okay, I said nucleus atom. Sometimes mind is not present, just like my mind is sometimes disturbed. Okay, R. Okay, R is equal to A naught A ki power 1 by 3. Okay, so if I consider the mass of aluminum atom is 27, if I substitute here 27 and I take the cube, it become like a calculation part. You have to calculate 27 and we can write as 3 cube and 1 by 3, it become 3. It's a calculation part. In the next video I will help you to solve the numericals, where what I already told you, A is equal to the mass number of that atom whose nuclear radius is to be calculated. I think this is the simplest version of video. Hope you all are able to understand these points. After that, my dear student, I want to tell one of the key concept. All the examiners in the JEE and NEET examination, they are asking these questions. You have to listen carefully that radius, they consider that the orbit also have a wave-like nature according to the dual nature of electron, but it is not exactly proposed by the Bohr's. We are relating with the Bohr's formulas. I'm writing only general explanation because I'm not going to teach in detail in this short video. Let's see, my dear student. Here, electron revolves around the nucleus, you all know. From the Bohr's formula, I can write 2 pi r is equal to n lambda by relating with the de Broglie hypothesis. I think you all know about the de Broglie hypothesis. Okay. So, or the circumference of the orbit, because the orbits are circular in nature, and you know the circumference of the circle is 2 pi r is equal to n into de Broglie wavelength. What the conclusion, what I want to tell you? I simply want to explain that the number of waves in nth orbit is always n. If I asked you that how many waves are present in the first orbit, your answer will be, tell me, 1. If I asked you how many waves are present in the second orbit, I am showing these waves by the red or orange color. Okay, you will say, sir, 2 waves because n is equal to 2. How many waves are present when the orbit number 3? 3 waves are present. Similarly, how many waves are present when n is equal to 4? The answer will be 4. 4 waves are present. So this is very, very, very important for MCQ questions for the NEET and JEE examination. They may ask the number of waves in nth orbit, then your answer will be n. If I ask how many waves are present in 5th orbit, please comment me. Answer will be 5. How many waves are present in the 7th orbit? Answer will be 7. And if the examiner shift from the calculation of the radius to the little higher level of the question, they may ask you to calculate the radius ratio. They will give you the 2 different atoms or the ground state or the excited state, and they will ask you to calculate or compare the radius of the 2 different species. They may be the same atom or the different hydrogen-like species. Some of the student will start applying the original formula and time consuming. They are asking only the ratio. No need to use the full formula. Always use R1 upon R2, radius of the first orbit, and the second, the comparison atoms whose ratio is to be calculated. If it is for hydrogen, okay, if this is for hydrogen, see, it is written hydrogen. For hydrogen, simply R1 upon R2 is equal to N1 upon N2, where N1 and N2 are the orbit number upon N1 upon N2 whole square. In this way, by using this formula, you can calculate the radius ratio of any atom, not any atom, hydrogen atom, because this is not valid for any atom, my dear. It is valid only for the hydrogen atom. And also, the examiner is very clever, very talented. Sometimes they will ask you to calculate the radius ratio of hydrogen-like species. So, don't be confused. You have to apply this formula for hydrogen-like species. R1 upon R2, N1 upon N2 whole square, and Z2 upon Z1, because this radius is inversely proportional. This radius is inversely proportional. Please take the screenshot of this so that you can memorize all these important formula. We'll meet you in the next video. Till there, thank you, and please share this video to among all the friends who is preparing for the school examination as well as for the NEET and JEE or any other competitive examination. And you can also inform me in the topic on which you want to have a video, the simplified version of the chemistry. Thank you so much for watching this video. We'll meet you in the next video. Till then, take care of yourself. Goodbye.